wait. For the same common amplifier, now we perform the AC analysis. This AC analysis is similar to our board light analysis, and we select from the analysis tab as AC analysis. Again, this AC analysis consists of 4 tabs: frequency parameters, output, analysis option, and summary. And in the frequency parameters tab, you have to set the start frequency and stop frequency, that is F start and F stop. And usually the default for multisim is the F start is 1 Hz and the F start is 1 millihertz and F stop is 10 gigahertz. Here my interest is I just select my amplifier frequency response I studied just is 1 Hz to say 100 megahertz. So I select the start frequency is 1 Hz and stop frequency is 100 megahertz. The sweep type, you can select the sweep type as decade, octave, linear. You always select the frequency while performing frequency. You select as a decade. The number of points for decade is the default is 10. You set it as 100. And the vertical scale, you may select as a linear, logarithmic, decibel, octave. You always select it as a decibel. That means your gain is in decibels. Next, in the output tab, here the output here my interest is just study the analysis, the AC analysis. That means the frequency response of my amplifier. Generally, the frequency response of the amplifier is a flat drawn between frequency versus the gain. Here gain is nothing but V of 6 by V of 1, that is output voltage by input voltage. So for that I just select my V of 6 by V of 1. I just selected as add expression V of 6 divided by V of 1 . So this itself gives the V of 6 by 1. It is nothing but the voltage. That is the voltage gain of the amplifier with low resistance. Now I start simulate. Next I select the less than. This is my frequency response of the amplifier, that is the magnitude class, whereas this is my frequency response of my amplifier, that is the phase plot. So for selecting the magnitude plot, you just click here. For selecting the phase plot, you just click here, then a red tab. This is the red tab. Okay. So first of all, we select the magnitude plot. You select it and you make it inverse. And next, grid. Next, you select the cursors. This cursors. So when I select the cursor, there are two cursors mainly. So you select the second cursor and right click and go to next to Ymax in positive direction, next direction. This itself shows that the maximum gain here is Y2, that is the maximum gain here is the 21.1810 at a frequency of 64.565 kHz. So my maximum gain of the amplifier is 21.181 decibels. For finding the lower cutoff frequency and upper cutoff frequency, I select the first tab and set by value in positive direction such that 21.1810 minus 3, that is itself is 18.18.1810. So this gives my lower cutoff frequency. So my lower cutoff frequency is 108.39 Hz. For finding the higher cutoff frequency, I select the second cursor and set Y value as 18.1810 because the maximum gain is 21.181. For getting the lower and upper cutoff frequencies, you just subtract 3, that itself gives 18.181. So this gives my lower cutoff frequency Here the lower cutoff frequency is here 39.1207 megahertz, and the upper cutoff frequency is 39.1207 megahertz, whereas the lower cutoff frequency is 108.39 hertz. The bandwidth of this amplifier is F2 minus F1, that is the lower upper cutoff frequency minus lower cutoff frequency. Therefore, it is itself simply 39 megahertz. Okay. Similarly, you can study the phase response. For studying the phase response, you click that. Next, you face the grid. You select the grid. Next, you select the cursors. This is the cursors. Okay. Next, you select the cursor 1 and cursor 2. And you already know the lower and upper cutoff frequency. So you first select the lower cursor. You first select the first cursor and right click. Set X value. You know the lower cutoff frequency, that is 108.3971. This is my lower cutoff frequency. So I set in the phase plot the first frequency, that is 108.3971. This itself shows that the phase angle is minus 123.0925 degrees. Similarly, I select the second cursor and set the X value, that is 39.1207 megahertz. This itself gives the phase angle of 124.7751. You just observe that. This is for the lower cutoff frequency, the phase is minus 123.0925, whereas for upper cutoff frequency, the phase angle is 124.7751. This ends our AC analysis.